next example 9-40. Here we have another function in which we have did in which we have another program in which we have a function of delay here, which is defined right here with the flags of counter, timer, and other timers as well, in which we have clear timers, etc., etc., and a loop here for a push button, I guess. So in this program, we have port B configured as output, and then another loop in which we have port B XOR with 0x10 exclusive OR with 0x10 hex value, and then another delay, a little bit of delay before the loop runs again, before another iteration. Let's see if it works on this simulation. So yeah, as you can see here, port 16 is getting toggled on off again and again. Let's do another thing. 16, here we have it. So yeah, actually the delay is a little bit on. It's just too small, so we are not seeing this LED getting turned. It looks like it's always on, but actually it's turning off for a moment. Next we have example 41, 9-41. Yeah, and in this example we have again function of relay here, which is defined right here, which is pretty much the same as in the last two examples. So here we have port B as output configured as output, and another while loop in which port B is getting XORed with this statement, or we can say a condition here, and it is also getting stored again in port B. Then we have another delay before the iteration runs again. Let's see what happens right here in the simulation of a circuit. Yeah, again port 16 is getting toggled on and off, on and off, on and off. So yeah, on to the next example of 9-42, and then next we have 43, which is the last one. So another function with a delay, another program with a function of delay right here. We have again defined the function of delay just as all the examples we have seen before in the chapter 9. And again it is getting XOR with this and getting stored in B again. This is pretty much the last. It is same as the last example, only a little bit of change for B right here. So yeah, nothing much to explain right here. On to the last example of what task we have been assigned. Thankfully, we have reached the last example, and then so let's see what happens here. In this example, unlike previous examples from chapter 9, we don't have a delay function here. Here we have 3 counter timers right here. In which this one here is counter timer and the other are for clear, I guess. We have configured port C and port B as inputs, and we have applied a condition on port D, which is, I guess, a pull-up counter or a pull-up timer, we can say pull-up timer 0. We have 8 bits at timer 0, actually 16 bits, not 8. So we have applied we have used a while loop here, and in that while loop we have used another condition which is do while. So as long as this condition is fulfilled, port C will be equal to the counter 0, timer counter 0, and this function will run, and then port B will be incremented. Then again we go to while loop and then do while, and this runs for as long as the condition is true. Let's see how it works in Proteus. So we are getting a signal and 29 and all others are low. So yeah, that's it for today. We have explained many examples from chapter 7 and a few ones from chapter 9. And we have simulated all those in the Proteus. And we have explained the code right here. And all those codes are written, all those codes are written in C language, not in assembly language and all that. All of them are C in C language. So yeah, goodbye. Until the next one, I guess. Goodbye.